Good morning, scholars. Welcome to the Kemet Maasai Academy. Today we're going to be looking at the circle. We're introducing the circle, so we're going to look at the terms and their definitions. So a circle is a continuous set of points around a central axis. So here we have our circle, and when we say a central axis, we mean, imagine a point here that every point along the edge of the circle rotates around, right? So this is our center of the circle, and all the angles in a circle add to 360 degrees. So the complete distance around the circle would, in traveling that distance, you would cover 360 degrees. Right, so we can divide the circle into quadrants, what we call quadrants. So for example, this would be one quadrant or a quarter of the circle, and that would be 90 degrees. Right? Two quadrants would be 180 degrees, three quadrants 270 degrees, and so on. So we keep adding 90 degrees all the way around. So then there are four quadrants in a circle. These are our four quadrants. The first quadrant, 90 degrees. Second quadrant, 90 plus 90, which is 180 degrees. Third quadrant, we'll add another 90 degrees, that's 270 degrees. And the fourth quadrant will take us all the way up to 360 degrees. That's a full revolution. Alright, so let's look at the different parts of the circle. The radius, and the plural is radii. We can also say radiuses, but preferably radii. So a radius is the distance from the center of the circle to any point on the circumference. And two radii make a diameter. So from the center to any point on the circumference, that's a radius. So it's not like we only have one radius in the circle. There are countless radii in the circle. So from here to here, that's a radius. We could draw any number of radii, right? From the center, so this is the circumference. Here we have the circumference of the circle. So any point from the center to the circumference, that's halfway. The distance halfway across the circumference, that is a radius. The chord, a chord is any line segment that connects 2 points on the circumference. Alright, so here we have our circle again. So this is the circumference. A chord is any line segment that runs from one end of the circumference to the other end of the circumference. So it can be any length, can be in any orientation, it can be slanted that way. It can run all the way across the middle of the circle, in which case it is called the diameter. So the diameter is the longest chord. It's a special chord in the circle that cuts the circle into two halves. Right? But we can have a chord running from anywhere. Once it starts on one end of the circumference and touches another end of the circumference, it's a chord. The circumference is the distance all the way around the circle, otherwise the perimeter of the circle. So if we wanted to, you remember perimeter is the distance on the outside of a plane shape, a plane figure. So it's just that we give a special name to the perimeter of the circle. We call it the circumference. And you know the root word is still circle, circum. So words like circumnavigate, circumvent, all of those words mean to go around, right? So a circle is a complete revolution. A complete revolution. And the circumference is the outer edges of the circle, the distance around the edge of the circle. Alright, now the diameter is the longest chord, and it cuts the circle in two halves. So it's a special chord that cuts the circle into two halves. This is the diameter. So these are other chords, but they are not as long as the diameter. The diameter is the longest chord because the distance along one end of the circle that cuts the circle into two halves would be the longest distance, right? And don't think the diameter is only drawn this way. It can be in any orientation. It can be slanted. It can be vertical. Once it cuts the circle into two halves, it's a diameter. Therefore, we're saying it's not just one diameter that a circle has. Each circle will have numerous, countless diameters. Once it's a line that cuts the circle, and remember the circle is a continuous set of points covering 360 degrees. So we really can draw the diameter in any orientation and it will still cut the circle into halves. So it's not that there's one diameter or one radius, right? There are many, many, many. Alright, so I need to write the definition for the arc. So the arc is a fraction of the circumference, right? So the arc is the distance on the outside of the circle, but only to a certain point. Therefore, for example, seeing as we have from the center to the circumference here and another radius here, this created here is an arc. The distance just from here to here, that's an arc. But the distance from here all the way back around to here is also an arc. So there we would really be saying there's a minor arc and a major arc. Right? So when the radius, the two radii touch the circumference, they automatically create two arcs. Automatically create two arcs. And the smaller one, so the distance from here to there, we'd call the minor arc, and the distance from here all the way around, we would call the major arc. Now, when we have chords segmenting the circle, cutting up the circle, we call the parts that are cut segments. And just like we have minor arcs and major arcs, we have minor segments and major segments, right? And the arc, two arcs cut the circle into sectors. So again, we would have the minor sector and the major sector. So you know that the sector looks like a slice. It's like you have a cake or a pizza and you slice it, right? So two radii from the center to the circumference will create on the inside of the circle will create sectors. On the outside will create arcs, the distance on the outside of the circle, right? So we have arcs along the circumference, sectors on the inside, and where the chords cut the circle on the inside, we have segments being created. So by definition then, a sector is created wherever two radii divides the circle, right? Where two radii, so one is going there, one is going there, two radii cut up the circle, we create sectors. Minor sector, major sector. And the segment is created wherever a chord divides the circle. Therefore, the diameter will divide the circle into two equal segments. Two equal segments. Any other chord will divide the circle into a minor segment and a major segment. So let's look at the relationships between the different parts of the circle. Right? Let's look at how do they relate to each other. So we said two radii make a diameter. since the radius is the distance from the center of the circle to the circumference, if we were to extend this in the opposite direction, we would create a diameter, because the diameter is the longest chord. Remember, the longest chord cuts the circle into two halves. So along this center, from here to the center is a radius, here to the other circumference would be another radius. So two radii make one diameter. Alright, two radii make one diameter. Alright, therefore, if two radii make one diameter, it stands to reason that half of a diameter is a radius. One radius. Okay? Half of a diameter is one radius. Two radii equal one diameter, so half of a diameter is a radius. Alright. So, a full circle, we said, is a 360 degrees. Complete revolution around the central axis. 360 degrees. I remember for the 4 quadrants, so each quadrant is 90 degrees. First quadrant, second quadrant, third quadrant, 4 quadrants in a circle. Each 90 degrees. 4 times 90 gives a full 360 degrees. So the relationship between the circumference and the diameter, and we're going to be there, I'll do another video just on the relationship between the circumference and the diameter, so look out for that one. I'll also be doing videos on finding the area of the circle and finding the perimeter of the circle, so look out for those videos. So mathematicians discovered, after doing many experiments, they discovered that there is a special relationship between the diameter and the circumference of any circle, of all circles. So they realized by doing measurements that if they took the measurement from along the diameter, from one end of the circle across the longest chord, the longest distance across the circle, if they took that measurement and then they got the measurement for the circumference and divided those, they always ended up with this number, 3.14. It continues, it's a continuous decimal, but we usually round it off to 3.14 as a decimal, and we also express it as 22/7 as an improper fraction. This special number is called pi. Pi, the Greek letter pi, and this is the symbol for pi. So we're going to do that experiment in the video that we're going to look at the relationship between the diameter and the circumference. And you're going to see that when you take the measurements along the circumference and you take the measurement along the diameter and divide the circumference by the diameter, you will always end up with 3.14 or 22/7. That special relationship, that special number, we call it pi. And we use it to find whether we want to find the circumference given the diameter or the diameter given the circumference. Finally, the arc, we said that's the last definition I wrote, is a fraction of the circumference. So when you get further up in your studies, you'll be doing courses that require you to find the arc, or find the area of the segment or the area of the chord, that kind of thing. And we have to use this relationship between the arc and the circumference, knowing that the arc is a fraction of the circumference. So we would express it as in degrees as a fraction of the 360 degrees. We'd use that relationship to find whether we want to find the arc or the circumference or the area of the sector or the area of the segment, that kind of thing, right? So these special relationships between the different parts of the circle enable us to do our calculations to find any of the missing parts, right? Given information, read the other parts. So I'm going to wrap up this video, the introductory video to the circle. Remember to look for the video on the relationship between the circumference and the diameter, the relationship between the diameter and the radius. Given one, how do you find the other? As well as finding the circumference of a circle and finding the area of a circle. Alright, so look out for those videos, and hopefully you have benefited from this video. So just drop a comment to say thank you, miss, and share the video so other students may benefit from the information. If you have not subscribed, I would encourage you to subscribe now, and let me know if you want me to do a video on any topic that you're looking for that you haven't found any video on that as yet. Just let me know and I'll do that topic for you. So scholars, thank you again for coming to the Kemet Maasai Academy, and I'll see you in the next video.